So yeah, this is supposed to be practice, and there are some things that I know I'll have to fix, but I want you all to tell me what you don't like and what you do. I would like to have more graphs and diagrams in the future, and I'll want your help figuring out which things could use pictures, which things are good as text, which things are just good with me talking. And also, this is a very text-heavy slide set because it's the first version. Sorry about that. But I really do want you guys to interrupt me. So like, if you think this slide could be better, just like say, yeah, how could I?
Black on white, not gray.
Like actually?
Yes, really.
Okay.
High contrast.
High contrast.
Yeah. And I will actually take notes because I want my tutorial to go really well, and I think you guys will have some great input. So, with that said, let's get started. Hi. This is a tutorial about scraping the web and pulling data out of websites that don't expect it. You're going to learn some cool stuff in this. Some of this will be reviewed for some of you. I think the basic idea is to cover a bunch of ground and a fair bit of depth. So if you've seen these topics before, I might hit at 1 or 2 points you hadn't seen before. If you're totally new to web scraping, who here has never written a scraper for any kind of web page before? Great. So I think you folks will learn quite a bit, and yet there will still be things that are left poorly explained or confusing, and I'll want your help identifying those. I do want you all to respect the web and the nice people who run websites and the nice people who use them. There's a lot of great stuff you can do with these tools. The way this talk will go is that I'll sort of explain a concept, and then I'll just dive into some code that implements that concept. So I'll also need your help in paying attention to the code, and I'll need to know what code makes sense and what you like there. And I just want to do want to say at the beginning, a lot of people seem to claim that web scraping is very brittle and websites are going to break it all the time. But actually, it's really, in my experience, not as brittle as it gets a reputation for. There was a website that I was scraping years ago when I was a student at Hopkins whose layout did not change. Like, I got there in 2002. I left. 2 years later, it was still the same backend, serving the same terrible nested tables. Like 6.5, 7, 8 years later, it was still the same. So a lot of the web actually doesn't change. So don't worry too much about scraping as some brittle thing you shouldn't do. And there's 1 or 2 comics in here. Those aren't mine, but I'm happy to tell you where to get those comics and give them credit after that. Fixme.com indeed. I think there's one other Fixme still left in here, sorry. So I'm going to be going through a bunch of sample code at the end of this talk. Maybe I'll write that down. At the end of the talk, I'll have a download URL for you if you give me a few minutes to put it online. If any of you have your laptops and you can install Firebug, which is a Firefox extension, or the Chrome DOM inspector, you should definitely grab those. And there's this module, Lxml, which if you run Debian or Ubuntu, you can just apt-get install. If that's easy, do it. If you're on a Mac or something, then it's probably hard, so don't. Or Windows, probably also, I don't know. Yeah, so again, I want you to, if I'm talking too fast, tell me, or if I'm talking too slowly, yeah.
Mac, you can use pip.
Probably.
I have.
Okay, great. Cool. Yeah, and if I'm going too fast.
You can repeat that? Pip.
On a Mac, if you want to install Lxml, which we'll be showing a little bit of here, you can just do pip install Lxml. Nice. Yeah, so slow me down or speed me up as we need. So the structure of web scraping is that you download some web page, you get some information out of it, and maybe you do it again. So one of the big questions that drives what kind of scraping tools you use is, are you getting just one page? Do you just want this enormous sea of HTML? Do you want to understand it and pull some data out of it? Or are you trying to get information out of a whole site? That's one of the things that makes a big difference in the tools you use. And another big thing that defines your choice in terms of what scraping tools you use is, do you just want the site's contents at the moment, or do you want to be able to repeatedly get the site's contents like a year later, 2 years later, or maybe every 15 minutes or something. So if you're getting just one page, well, where's this? Sorry, just a sec. Yeah, so I just want to, most of what we're going to talk about is sort of future-proof scraping, like you write the code in the interactive prompt, you write the code in a script file or like a .py file, and you execute it, and then you can just execute it repeatably a day later, an hour later, whatever you need. But if you're just scraping the contents of a website right now, you can usually get what you want by just playing around in the interpreter. So we're not going to talk about that a whole lot, but it's even easier than what we're going to do today. So years ago, when I was working in San Francisco, we would frequently eat food from this Indian restaurant down the street called Methil. And this is what the food looked like. I was curious, so here's the menu. And I want to take a sec to just show you all what this menu looks like. And now I realize I don't have a web browser. So here we go. This is what we would check every day before heading down the street to get Indian food. And we would see what they had and how much it costs. You can check this manually, but if there's one dish that you really know you want, you could just download this page once a day in the morning, see if the string for that dish is in there, and if so, send yourself an email. And if not, then you know not to bother. So for me, the question was, will there be eggplant in something that I could eat today? Because I really love eggplant, especially the way they cook it. So today, let's just take a look at the page as a human. Seems like there is the word eggplant on this page. But what I'll show you right now is a quick bit of sample code as to how to download this web page, pull out the HTML, and check for that string. Well, let's do it here. So it's exceedingly simple. Have any of you not used urllib2 before? Or rather, yeah, sure. How many of you have not used urllib2? Sweet. So the basics are really just you import this library, you use this special method, whoa, wrong button, sorry. You use this special function in the module called URL open, which acts similar to the open call to open a file in Python. And you pass it a URL instead of the path to a file. It gives you a file object, which when you call read on it, gives you a string. And this will print true if it's true and false if it's false. So let's try it. Wow. True, except that my window is kind of truncated. Let me
And your
fix
prompt
that.
is half your screen.
What did you say?
Your prompt is half as wide as your screen.
Yeah, isn't that great? Let's see.
Awesome.
What? Yeah, opposite direction.
It's kind of shrinking that down.
Okay. Yeah. Is it still true? Great. So notice that in doing that, we didn't pay any attention to HTML at all, actually. Can anyone see any other problems with this code? Well, other than the fact we don't close the file object, which we should. Yeah.
Case sensitivity?
Yeah, so if they capitalize eggplant, then we're hopelessly lost. Okay, so that one's easy to fix.
Or you just take out the E.
Yeah, that's right. But maybe they shouted the whole word eggplant. Yeah.
If they said there is absolutely no eggplant in this dish at all, then it's
That's true. That's kind of outside the scope of this tutorial.
Being an ethnic restaurant, they might have spelled eggplant with a space.
Yeah, they could have called it
Or-
aubergines
Or
also.
aubergines, yes.
Actually, that's pretty common among Indians. Yeah, and the other more subtle issue is that HTML source code can contain ASCII. They could have done something like this. They could have escaped one of the letters for some reason. Maybe their content management system decided that this was a better way to represent one of these letters, 95 or something. That's what ampersand, thanks. I think that's approximately the right letter. It might be off by a few. And then we would fail to find it. Yeah?
They could call a CSS class eggplant.
That's right. They could have called the CSS class eggplant. They could have maybe it's after the name of the restaurant, or maybe it's in the footer. Maybe it's in the wrong part of the page somehow. Either
Might be a
it's
valid
tag.
color.
Sorry?
It might be a valid color.
To repeat that, eggplant might be a valid color in HTML and CSS. So maybe they're just coloring the header.
Might be the name of an image file that's included.
Yeah, and it could be the name of an image file. So this isn't quite perfect. In fact, we're completely ignoring the structure of this document entirely. So I want to take a quick look at HTML. Let's see, remember which one's which. Pardon me. Okay, yeah. So here's our great old web page again. Let's just view the source of it in Firefox. Okay, we'll leave it split screen for now, I guess. So here's, let's start at the top, sorry. So they set up some, well, it'd be nice to have this loaded. Great. They set up some style declarations. Some of you will notice that there's no HTML tag at all in this document. This is really like high quality HTML.
Saves on traffic.
Yeah, that's right, it saves them bandwidth. But they actually wasted the space having all these new lines. It was almost as many bytes as the HTML
The
tag.
indentation.
That's true, and they're wasting all the space in the indentation. But I think this pipe character is not just a pipe character. It's an Arial black pipe character, and it took all of these bytes just to encode this pipe character and make sure that it was black, which probably is the default. They do double indenting in block quotes so that they can store the date and time here.
It's pasted from Word.
Yeah, so you can see that it's pasted from Word. There was this MSO prefix indicates Microsoft Office was involved. It's whatever's the best tool for the job. That was kind of a surprise that it's the best tool for the job. In many HTML documents, they might use a table or CSS class or like a div or span or something to separate the price of this menu item from the description of the menu item. But in this case, the closest we can get is a new line between the description and the price. Yeah, but so this is one way to view HTML. This is the text that they send us. Do I have Firebug? No, I don't. Wow, I didn't install my own dependencies. Yeah, I'll just install it. Sorry. Yikes. Sure.
For those of you who don't know Firebug, this is a really good thing to write down. If you're
Yeah.
going to be doing this kind of work, this is absolutely essential. And I applaud Asheesh for including in his tutorial a demonstration of how to install it.
Why do you like Firebug rather than the Chrome tools?
I've been using Firefox for longer. The Chrome tools are really good too. For what we'll be doing, they're totally equivalent. I think this is what I'm doing. This looks great. Just a directory of XPI files.
I'm sure it's fine.
Yeah. I mean, I'm sure it's fine. It's just not the most polished thing in the world, but that's okay. Oh, and also I'm using iceweasel on Firefox, but that's another story.
What was that?
Sweet. I've gotten firebugged. Yeah, so I showed you the view source view of the HTML. You can use inspect element, which, like somebody just said, works also in Chrome using Chrome's DOM inspector, and in Safari and other browsers probably too. This shows you a pre-printed, parsed, interactive view of the document. And this inspector might, if some of you have not seen this inspector, I think this is the most useful thing you will get out of this presentation. You can mouse over sections of the document, and it'll show you which sections they are. So these, um, so this span you can see here at the bottom. This indented, nice, pretty printed thing is a lot easier to read than the HTML source that we saw in the view source view. Where is my? Yeah. Yeah. So inspect element is usually actually the easier way. Yeah.
You can get in trouble because the inspect element is a fixed HTML rather than the actual, because you'll see that HTML tag is in that inspect element rather than when you view the source it's missing.
Right, yeah. Just to repeat that, when you see the source in the inspect element view, so we notice that this document has no HTML tag, and yet one has been synthesized right here, right where my mouse pointer is. In some ways, you can get in trouble because the structure is slightly different in the web browser, but actually this is kind of the correct structure. So you almost get in trouble looking at the code, the source code, rather than the inspect element, I would say.
Is there any way to have it colored so you can see what was added versus what was there originally?
No, I've never seen a way to have the browser show you which HTML tags were synthesized. Yeah, we'll talk a little more about buggy HTML. There's a lot of buggy HTML in the world. So some of you might have heard of XHTML, which I think was supposed to take over the world. The HTML came around in like '92, and XHTML is from the year 2000, so it's clearly from the future. So any quick sense? Did HTML take over the world?
No.
XHTML?
Yes.
No?
Yeah.
Yes? Did I hear a yes somewhere? Yes! You
Secretly.
must be living in a different world in which software works and people are wise. So I'm going to pause here for a quick quiz on the state of the web. There's a great survey where the folks at Opera downloaded huge portions of the web and analyzed it and generated some statistics. Can anyone make a guess as to how large the average web page is in kilobytes?
5K?
5K. Any other guesses?
One.
Take two more guesses. 1K
One.
and
2
10K.
megs.
What do you say?
2 megs.
2 megs. So Glyph's somewhere closer to reality. It's 16.5 kilobytes, which is, I don't know, pretty reasonable, not enormous. Glyph, this one's for you. What's the ratio, as of 2008, admittedly, of HTML to XHTML on the web?
HTML is the numerator?
Yeah.
1.
Like 1 to 0.
2 million measurement error.
It's actually not that bad. It's 2 to 1.
Oh.
Wow.
There's a lot of, at least in terms of what types people claim their web pages are in the document, in the DTD doc type section.
So they didn't actually validate.
Well, we'll get to that. Right. So there's these subcategories of HTML. So in the XHTML transition, there's XHTML strict and transitional, which is supposed to have some of the deprecated elements of HTML4 still stuck around. Anyone? Well, I'll just tell you that there's much more of the so-called XHTML. Vastly, most of it is this transitional kind. But okay. Web browsers have this mode called quirks mode. There's approximately 2, although maybe 3 or 4, different ways a web browser can render a web page given the very same HTML code. There's standards mode and quirks mode. Web browsers look at a web page and they say, oh, does this thing look like it's expecting was it written with web standards in mind? If it was, the web browser uses standard mode. If not, it uses quartz mode. And most web pages, you still render in quartz mode. Even actually, a huge proportion of the XHTML pages. So how many of these web pages validate? Anyone want to guess what percent of the web validates as proper HTML or XHTML according to its declaration? Yeah. 10%. Any other takers?
2%.
2%, that's Oxford. So it's about 4.
Wow.
But you know, okay, so web pages are going to be invalid. Some of you already know that body is an essential tag in HTML. Title, inessential, but pretty cool. It gives the web document a title. Which one is more visible on the web? Which one do people use more?
Title.
The body is required. Okay. Because title actually does something. The person use it.
It's maybe a little too close.
Yeah, so some web pages claim to validate. Right, there's little W3C, click here to check me. Presumably, all of those validate, right? Anyone want to guess how many, what percent of those validate? We're going against 4%, so it's got to be higher than that.
10.
Like,
Doesn't have to be.
75.
so it's about half. That's not terrible. But yeah, the web is a big mess, and the fact that our document had no HTML tag is kind of odd, of course. I wonder if it had a body tag. Also, I wonder what they did to make Microsoft Office generate an HTML file without an HTML tag.
They just didn't span the whole thing before they cut and pasted, probably.
Yeah, give me a cut and paste error. I really don't know. I should go interview them, I guess.
Did it have the close tag? It might have had the close tag.
Oh,
It
that's
did
a
have
really
it
good
does
question.
have a close tag.
Did we check? Hold on, I really want to know now. Do we have the close HTML?
Yeah.
Yes. Okay.
It's got
Okay,
it
that's
has a,
great.
has a
Oh my
body
god,
tag.
this is phenomenal. They close the body tag, and then they close a font tag. It's all over. It doesn't matter anymore. Yeah, so that's the web. It's really remarkable that it works. So when you're parsing HTML in Python, you're really parsing HTML. And one of the really important questions is what your parsing library does with invalid HTML. This used to be a really tough problem, and also it doesn't handle XHTML. They all do, so that's not a big deal. There's some sample code in the samples file, which I'll be delivering to you all shortly-ish. Here is a list of 2 reasonable sounding HTML parsers or XHTML parsers that are bundled in the standard library. HTML parser is actually reasonably okay, but if you have an XHTML page, you might think to use an XML tool to parse it, but it's probably going to give you a syntax error from the junk we've seen, and so it's not even worth trying. There's a few others that are worth trying. Beautiful Soup was the old standby since like 10, 12 years ago. How many people here have used Beautiful Soup? Yeah. Okay, how many have used HTML5lib? And LXML.html? Okay, good. So these last 3 are all pretty reasonable choices. And I'm going to take a second now and just show you what the code looks like if we are to parse a document in each of these. Yeah?
I don't remember, maybe I don't remember correctly, but isn't Beautiful Soup now deprecated?
I was going to talk about that later, but I'll just
Okay.
talk about it now. I'll just say briefly that it's come back from the dead.
Okay, cool.
Let's see. Let's see sample code. So in the samples directory, there's some invalid HTML, there's some invalid HTML and XHTML, and valid HTML and XHTML. So let's first take a look at HTML parser. This is the one that's bundled with the standard library. I don't like it. There we go. So with HTML parser, it's you use it in an event-based way, or which is similar to Stacks if you've used that view of XML parsing. This is a simple HTML parser instance that takes an HTML document as input and just calculates the title of the document. So it's implemented as a class that's we store the title eventually in a class attribute, document title, and we'll use this in title flag to, as we loop through the document, basically as we descend into each tag, we'll find some text. If the tag was a title tag, we'll copy that text to the document title attribute. Otherwise, we'll just keep looping, looking for the right time to copy the text. Did that algorithm make sense? Or did it not make sense to anyone? Okay. So I kind of wish this text were smaller. What a surprise. But yeah, so the way that we call it, maybe that's the simplest place to start. The way that we call it is by creating an instance of it, and for some reason I pass it every line, line by line, and then I close the parser object, and I pull out this document underscore title attribute. And so the way what it'll do is the parser, when it runs into a start tag, it will call your handle start tag method. If your tag was title, then we flag ourselves knowing that we are in the title. Whenever there's text data, the HTML parser will call your handle data method. And so we've set this flag. If you're in title, then we append that data to this attribute. Otherwise, we do nothing. And if we're at the end of the title tag, then we set the flag to false. So this code does actually work. I'll show you right now, actually. So let's just look briefly at sample.html. The title of this document is Yohoho. You can see it's gorgeously compliant HTML 3.2 with body / body, great stuff. Sample HTML, great. These are just the standard error prints that I had. Most importantly, it pulled the title out fine. So let's try it on some XHTML, which it does fine. Whoa, sorry. Some invalid HTML, an unclosed title tag. Let's read this invalid document.
Yes.
So this document, what is the title? Well, it's kind of unclear. Maybe it's this whole string, because we never close title. Maybe it's just this. Or maybe that we should just declare the document is hopelessly bad and then throw it entirely away. But you'll find stuff like this on the web. An HTML parser will actually get it wrong. It considered the title to be this text plus this text, because I expected a title close tag to turn my flag off. Why don't we actually just look at this in Firefox and see what it thinks it is? Wow. Okay. Let's see what happens. One second. Also, due to technical difficulties, there's two computers involved in this presentation, which makes everything harder. Sure. Okay. According to Firefox, the title includes the p/b, which is kind of surprising.
Try Chrome.
What do you say?
Try Chrome.
It actually has the yo on it too.
I'll try Chrome. What did you say over there?
It has the yo on it too. It should stop.
Oh yeah, but okay. So HTML parser and Firefox disagreed because Firefox thinks this p tag thing should be part of it, which I'm still really surprised by actually.
But it's not a bug, right?
Which version is it?
Which version of Firefox?
It's probably 3 point. Does it help?
Yeah. I think this is version 9-ish. Yeah, this is version 8. Also, it's again iceweasel, but it's the same. That's really weird. I'm really surprised.
The web is surprising.
What do you say?
The web is surprising.
Yeah, it's a crazy place.
It's probably looking for a body tag.
Yeah, maybe. Boy. Anyway. Yeah, so I can try Chrome. Wrong window. Oh, and now it's going to show up here. Hooray. seems like.
Brackets.
Well, I saw it on this computer here, and it does include the p tag in the title when it finishes loading.
Series
Okay.
analysis.
Yeah. Yeah. Same as Firefox. Huh. Okay. Well. Wow. I don't even know what the other tools will do. Actually, I should totally test this some more.
Well, the content model for title is probably only text.
Yeah, the content model for title is probably only text, but the paragraph tag can only be inside a body. A title can only be inside a head. So I would expect the browser to synthesize a head and a body, and to synthesize the body right at the beginning of the paragraph.
As opposed to just interpreting the paragraph tag as text,
Yeah, as
which
opposed to
matches
just
the title model.
yeah. What's up?
Since we're scraping it ourselves, does any of this actually matter?
Well, long story short, in the details, no. In general, yes.
How so?
Your choice of HTML parser will, given the buggy, trashy nature of most documents on the web, your choice of parser may or may not line up with what web browsers experience. So you want something that's maximally aligned with web browsers, since that's the way the document was designed to be interpreted. Yeah, and knowing the nitty-gritty of exactly what that is not actually necessarily crucial. Um, so you can parse XML with mini DOM. With a valid XHTML, this will probably work. Let's see what it does briefly. On the invalid XHTML, it just breaks in half. Uh, and on the sample HTML, yeah, and on the thing that's HTML, that's not XHTML, mini DOM also breaks in half. So basically, don't ever use it, unless it's really not scraping, unless it's actually an API, in which case it's perfectly fine. Uh, and Lxml and HTML is pretty simple also. It'll look kind of like the mini DOM call, except it'll be simpler. It'll look a lot like that. So some of you may have heard this sort of quote, that it's considered a bad idea to use regular expressions when scraping the web. And I want to reflect for a minute on why. So if there's imagine these three inside angle brackets. The first one is valid. The second one is valid. You could write a regular expression that could match the first one by looking for ahref. Let's say you want to find out what's inside the link. You want to know what the target of the link is. So you're like, I know. I live in Perl land. I'll use a regular expression. So you get to this text and you're like, sweet, it's text. I'm going to look for ahref equals either a double quote or a single quote, some string, with either a double quote or a single quote. The first and second one are valid under that analysis. For the third one, you'll match this whatever string, but actually the full URL isn't over because you can jam in a standards non-compliant way. People do jam apostrophes in the middle of URLs inside links that are shrouded with double quotes. But if you're using a regular expression, you can't tell the difference. You don't keep track of what delimits the URL. So you're like, sweet, you get to this first one, and you're like, sweet, a delimiter. You get to this last one, and you're like, sweet, a delimiter. But actually, the URL might continue on until the double quote. Yeah?
Just perfectly valid HTML can break and not use regex there too. They could have a class tag in between the href and the a.
Yeah.
They could split it on a line.
Oh, that's easy. Just do re.all. And the first one, it's easy. Just use a character class for not angle bracket instead of space.
In the old days, they could have not used quotes at all.
That's true, and that's right. They still could. They could just never use quotes. Yeah. It's actually, in a way, it's sort of the nitty gritty of correct HTML that breaks. That's one of the things that really breaks regular expressions. HTML is not a regular language, and it actually, strictly speaking, cannot be parsed with regular expressions. There's a little footnote here that says actually regular expressions, as we use them in computer science, are not about regular languages because Perl made it all crazy, but that's a different story. But yeah, you would have to write your regular expression carefully, and by the time you did that, you could have just used someone else's tool that was also correct. So just don't. Except the curry example, I just wanted to know if eggplant was on the page. It was good enough. I was lucky. I'm probably, from now until the end of time, always going to be right by looking for the string eggplant, maybe case insensitive, on that page. And if you're looking at a string, like, you're trying to look at the pagination on a page, if it's text that was generated as text, not as HTML, then it makes sense to use a regular expression to grab this number here, these numbers here, but don't use them for the actual HTML data. Use them for the text inside the HTML. And if you had to, there's this great GUI program called Kodos. How many of you used any sort of how many of you use regular expressions at all? Yeah. How many people have used some sort of regular expression GUI that lets you visualize how your regular expression is being parsed and what it will match? So they are totally flipping awesome, and you should all use them if you're using regular expressions. The one that's most maintained is a desktop app called Kodos. You should use it. If you have to use regular expressions at all. But it's really convenient. It'll let you do things like, if you type \d+, it'll highlight in blue this number 1, this number 10, and this number 430. And as you change the expression, it'll change what gets highlighted to show you what matches. But you shouldn't use them very much, so there's one thing to consider when scraping the web, also, which is called the robustness principle. That's one of the foundations of the internet. It's by a fellow named John Postel, who used to maintain the list of computers on the internet. You're going to see all sorts of nonsense on the web, and as web programmers and also as people extracting data from web pages, try to generate high-quality stuff, no matter what trash you're given. You actually usually can't do that with regular expressions. So I'm going to talk a little more about these different parsers. And I'll show you a bit of code here. So one of the things you'll have to do, usually you don't just want to parse documents and find really simple things like a title. You'll have to do more complicated searches inside a document, like find a table inside a link, inside a heading. Maybe that's backwards anyway. So I want to take a second to show you how you do those kind of searches with different libraries. Let me link. You can get all the text in there and you'll see the string. So I'll run that. So there's these two different links that go to menus, something including menu.htm. I guess when I last ran this, they didn't have a Fillmore Street delivery subdivision. Separate takeout menu for it too. But this got generated from these two. This contained a list of two links that link to those two menus, and so this contained a list of all the text inside those. As a side note, because Beautiful Soup is actually parsing the document, and it's pulling out just the text inside the tag. It's skipping any italics or bold and just removing any special decoration for that text. So I've actually used the same functionality in web apps to sanitize text that have passed to me by the user to remove all tags. Is it clear what this is doing, or shall I?
You could go a little in detail.
Okay. So maybe it'd be a bit simpler if I show it interactively. So this just pulls out the parse document. When you just type tree and press enter with beautiful soup, you see its representation of the whole document. You might remember the document ended with a /HTML, or it had a slash body and the slash font after the slash body. Beautiful soup has normalized that away because it just couldn't make sense of that slash font after the body was closed. If you want to look for all the links, you do that. There's a lot of links. How many? What is this thing? Is it just a list? Yeah. So the length of that list is, sorry, 16 links. And because it summarizes each of those items as the repra of the tag object. We can search for just the ones that link to more. There's 2 links that go to the still more location, and we can pass in a function here like. Oh, I guess I'm using lambdas, which not everyone might have seen.
Yeah.
Does more like it. So we can filter just by getting just the links whose target looks great according to our custom function. Of which, what? How many are there? Of which there are 4, which is not the same as here because question mark? Well, this is why I use code that I wrote in the past rather than how to write code. Well, I'll let that slide for now.
You're missing the
You have 2 occurrences of both names.
It's because I'm calling them.
Yeah.
Is that what you were saying?
Yeah.
Yeah, that's. I don't even know what I did before. What? Okay, so first of all, this should give me 2, but doesn't.
2 occurrences of 2 names. You would take out menu in the full insert menu.
Okay. Yeah. Right.
I think 4 now.
Yeah, they're just duplicated. I don't know why, but that's them. Yeah. So even though you can say this demo didn't quite work great, I think this is actually the downside of the Beautiful Soup API, which is that it's so exceedingly convenient, except that it offers you so many different ways to say the same thing that you can't tell what you're saying anymore. So I actually haven't used it in many years, which speaks to this problem right now. I much prefer to use. Well, right. Okay. So it's worth mentioning HTML5lib, and then I'll come to the one that I like to use much more. HTML5lib actually. Parsing a document with HTML5lib is very simple. You instantiate a parser object, you pass it either the file object path given to you by URL open or the actual string. One of the weird things about HTML5lib, well, HTML5lib was created to emulate current web browsers' behavior on weird web pages. It's supposed to be like, this is the standard for what HTML5 is. HTML5 is this ultimate, on one hand, exciting, novel addition of things like video to the web, but on the other hand, this depressing acknowledgement of the truth about web page parsing. And so it standardizes all the broken behavior. HTML5lib is a Python implementation of that standardized broken behavior. Which sounds great, because it means that your Python code can do very much the same thing as these web browsers have been doing all along without standardizing it. You can ask HTML5lib to give you a bunch of different kinds of trees. Once it has computed what the parse looks like, it can then create you something you can use with xml.dom.minidom if you like using XML type actions on an HTML page, You can request a beautiful soup tree, or so on. So if you request the beautiful soup tree, then the way that you search the tree will be just the same because you get to use the beautiful soup API. And if you use lxml.html, the parsing looks very similar and very simple. You just parse this object and get the root of the tree. LXML has a kind of suspicious sounding name. It seems like it's going to be an XML tool and therefore throw up whenever you pass in invalid documents. But lxml.html actually is very lenient. So it's safe. Well, it's relatively. And searching those, you can search with XPath if you want. How many of you here have used XPath? And how many of you like XPath? Okay, yeah. So for you people, you can query with //a, and like, of course, I'm gonna get all the A objects with that query. But my favorite feature of LXML is that you can use CSS selectors. How many people here have written or read a CSS style sheet? So many of us have experience with CSS. jQuery also uses CSS selectors as part of its selection model for searching the document. So I actually think that CSS selectors are by far the simplest way to search HTML documents. It's really, really great. And if you like XPath, you can have it too. Actually, LXML compiles the CSS selectors to XPath and then executes the XPath. So in general, when you're scraping a page, you download the HTML file, you parse it, and you somehow get out some structured data. So maybe you want to find out where all the links go, maybe you want to find out in this big sea of content on a page, what the content, in a big sea of like navigation and content, what the content is, like the lyrics. Yeah?
When using the LXML .html, do you find it does as good of a job parsing the junk HTML as what HTML5 does, or is it equivalent?
Yeah, long story short, yes.
Okay.
So I want to take a second to revisit this card example once more. Although I don't know what I'm looking for. Wow.
Actually, Asheesh,
Yeah.
LXML also includes an HTML5 parser that uses HTML5 to do its parsing, looking at the LXML data structure. So if you want like that
Right.
exact thing,
That's right.
you can get it.
If anyone didn't hear that, LXML does let you use HTML5lib to parse a document, and then you could use LXML CSS select if you want. Is that another question? Or? Yeah.
Yeah, your curry document you're visiting is multi-rooted. What happens when you ask for the root of that piece of code that you just showed us?
Is it
Well,
multi-rooted?
there's no head tag, so it's got multiple heads, multiple roots, right?
That's an interesting question. It's true that in theory the curry document is multi-rooted, but in practice, because all these HTML parsers, if they are smart, will synthesize an HTML doc tag at the root, that becomes the root that they find. So, yeah, I'm going to take a note of that. Yeah, actually, let's get this silly thing. So what we've seen from all this is that this curry document looks kind of handwritten. I mean, it looks kind of like they exported a document from Word once, and then they edited Notepad ever since, and they once accidentally stripped off the beginning, and they never fixed it, which is just kind of amazing to me. There's also really nice machine-written pages, like WordPress, for example, almost definitely generates correct HTML unless you install some plugin that ruins it all. And the Microsoft Office generated example is somewhere in the middle, where sure, it probably generated valid HTML, but it took like this much space to mean a single character of a pipe. And also, modern web pages that are machine-written or handwritten by smart people contain things like spans and divs and semantic classes that mean something about the document. Things like Word just like spew this formatting all over the place. So the parsing strategy you'll end up taking will be very different between the two. like, you'll parse it into a parser just the same, but when you search, you'll be searching for particular formatting in the third category. You'll be searching for very simple CSS selectors in the first and second. So I want to show you guys a real-world example of pulling some data out of the web, finally. And we're going to check the stock price of Apple. Super. So this code is, well, I'll do it in the editor. Change this. Okay, this code is pretty simple. Apparently I import things for no reason. So the URL to getting a quote from Yahoo Finance is finance.yahoo.com/q/q?s equals the ticker. So this is actually really typical scraping code. You calculate some URL based on the inputs to your function. You grab the URL. You turn it into beautiful soup, and you pull out a table row, a table column, and you find all the text there. You can also chain those together like this. And it might seem like I totally made that up. In the past, I did it by inspecting the document. So let's take a look at that before we run this. Back. No more Firefox. Come on. All right. 34 minutes to go. Maybe I should add T here.
Do Nokia next.
Nokia? Okay. So, wow. This is totally
You
different.
type in the search box instead of the quote box.
Right. Except that actually, those two look really similar. Anyway, yeah. So this is the actual thing I wanted to search for. Where did the quote go? Here it is. Fallen out of junk. But that's the important part, right? Great. Wow. That's terrifying that people are putting text ads on other people's shares and scaring them into buying and selling. Yeah, so, wow, this is beautiful, the HTML. There's like a list item, a div. Honestly, I don't know why this HTML looks so good. It didn't look this good when I wrote the scraping code. In fact, the scraping code can't work.
It's like you're on the wrong web page.
Q equals finance.yahoo.com. Let's see.
You're on search.
Finance on search, yeah.
Whoa. Okay, thanks. Thanks a lot. Yeah, still nice and spanny and dicky though. So I guess I should. I was hoping to introduce this concept later, but it seems I can't get away from it now. So this code actually works. At least it did like a few minutes ago when I tested it at home. Yeah, so that's the stock quote for Apple. Let's just check. 429.11,
Is
429.
Yahoo server sniffing the user agent to change formatting?
So your question was, is the Yahoo server sniffing the user agent to change formatting? And the answer is almost definitely yes. I would clearly have to rearrange my presentation to mention that at this point. But yeah, that's totally what's going on. Let me see if I can just zoom to that. Sure. So I'll just zoom. I'll break out of this and talk about searching the web with Yahoo and Google. So let's say you wanna. So one question that I had is, am I still the top Asheesh? Ned is not the top Ned so far. What number are you? Like
I don't know.
5-ish, 7-ish?
I can't tell anymore. Google personalizes everything.
Oh yeah. Is that there's a button you can click to depersonalize it? But yeah. So luckily, I am the top Asheesh, and we should check that to make sure it's still true. Let's search. Let's see some code that searches Yahoo. Uh, this is the base URL for searching Yahoo. We'll add whatever thing we want to search for, and with beautiful soup, we'll take the first thing this class is URL, and we'll print the text in it. So if we're lucky, I'll run this. I'll search for Asheesh. If we're lucky, it'll print Asheesh.org. Let's see. Yes. Okay. So let's just do some simple code that does the same thing for Google. Uses, say, a different search base, but basically the same. Grabs the first thing who's that's in a site tag. But it works on the web. So you pointed out, see, yeah, I am the top Asheesh, so what gives? So yeah, I think you're right about this user agent thing. So let's take a look at what headers get sent when we do a search. We can use Firebug's net console. Maybe. Yes. So when we do this request, this get contains a bunch of headers. Yes. So when we requested it, I told it the host we want to talk to is www.google.com. Our user agent is blah blah blah. I squeeze blah blah blah. We hope we hear English back. We'll accept compressed stuff. This user agent header is what we're supposed to send, what every web client is suggested to send every web server, saying what kind of client it is. Servers, I think it's, I don't know if anyone's read the HTTP RFCs recently, but I think they must not change their response based on your user agent. But, I mean, Google actually outright blocked me. They gave me 403 error instead of 200 response. Okay.
There is not a possibility. Probably IP coming from Microsoft.
It could be that they block all of my response. I'm doing the same search right here. I mean, no, I did it without the rest of this junk, so let's just check that. Yeah. Yeah, so maybe there's something we can do to change the response we get back. So just to explain these status codes, 2 whatever in HTTP, like 200, which is what we got back in Firefox, means okay, 2 whatever means success, 3 whatever means you have to go somewhere else, and 4 whatever is an error of some kind. These are relatively common, okay, not very, some of them are very common errors on the web. Actually, there is a space allocated in the standard for payment required.
We're gonna figure out micropayments anytime now.
Yeah, so number 401 is unauthorized. And what it means is the web server says, hey, you're unauthorized, and you are the client. You receive that and say, oh, I know what to do. I should negotiate authorization with the server. So then you send it your username and password encoded in some way that's specified in the standards later, and it sends you, yep, 200 OK. 402 payment required, what's supposed to happen is you send a request for a page and it says, no, 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 payment required. And your browser automatically negotiates payment with the web server through a transparent system defined in some future standard. And you see the page. Right now, this is just reserved for future use. And so 404 is not found, it's pretty common. 410 means it'll never be found, you can stop asking for it, also in standard. And in an extension to RFC that finds hypertext coffee pots, 410 I'm a teapot, is an error that suggests that you're not going to get coffee from this machine. And there's these different methods in HTTP. You can get a page, you can post URL to a resource, which means you can post data to a resource, which may modify the resource, and you can straight up upload files. There's other things you can do too. And then again, this hypertext coffee pot protocol, an extension to HTTP. So we can set our user agent to Firefox. Let's see. Actually, I already have this set up, I think. So I decided to impersonate Internet Explorer, and there's a list of user agents that are available here. You can generally search the web for user agents you might like to try.
45 minutes.
Great, thanks. It's a little bit more complicated if you want to set headers with urllib2. You have to first create a request object, add a header, create an opener, call the opener, and then you get your data back, and then we search for Asheesh. So let's see if I'm the top on Google at least. Good. So I actually really liked Internet Explorer 5 on Windows 98. So I'm just going to change my user agent to that and see if we get back the same thing. So the web server, I actually I checked into this, even though the web server actually sends back standards compliant, pretty divvy and spanny HTML if you're using a standards compliant browser. And if you say you're using Internet Explorer 5, it sends you back some tag soup, just like I would have wanted. Netscape Explorer would have also loved it, so it's not like brand loyalty here. Yeah, I guess I'll leave that a mystery for now. But if you all try later, we ran into an example like that before, so I thought I'd emphasize that now. But
can we,
yeah,
if you don't mind summarizing, so that had nothing to do with sort of who you were, it just had to do with what browser you claimed to be using.
Yeah.
And why did the one you were initially claimed to be using, do we have any idea why that seemed to fail?
Oh, you mean with Google error? Well, so I presume, I haven't read the Google terms of use in ages, but I presume that they don't permit automatic access to the Google search. I know they do have a separate API you're supposed to use. And my position is that they're probably going to have better uptime on the web search than on the API, so why bother with the API? But, so because of that, they know that the default, Python by default with urllib2 sets a particular user agent header. So if you fail to configure it, you'll send something that says, "I'm seriously a bot, guys. Give me this page." And they'll be like, "No thanks." So that's the story there.
So one additional comment about that, just because I experienced this personally. If you have, let's say, a tutorial of people who are learning about web scraping and they all decide to fire this off at once, Google might decide to ban your entire net block.
That's right.
So probably don't do that.
Okay, yeah. Well, the threshold is pretty high, but yeah.
It's like 100 a day. So it's
100 like robot-y things a day?
Yeah.
Oh,
It depends on the rate you make them at, but
yeah,
we actually got like all of Pound Twisted banned at one point. Like, yeah, your whole slash eight's gone.
That's great. We should go to MIT and do that, I guess.
That's why you go to Starbucks first.
Yes.
That's right. If you all, we'll actually talk about using other IP addresses than your own later in this talk. So, I mean, it says don't be evil comment spam, but there's a lot of like non-evil, non-comment spam things you might do that might get you blocked. So, and if you're just doing your research and you want to find out what gets you blocked, you might as well research on not your own address. But yeah. So your point is really interesting. That it's not the resource you requested. It's not who you are. It's just what browser you claim to be using that got you this wide range of permissions denied to tag soup to standards compliant Vivi. But there's other ways that web servers can identify you just other than your user agent. One of the big things is that this little Mechanize thing. Where are we? Pardon me. I guess I need to. Okay. Yeah, this little urllib2 thing doesn't execute any JavaScript. So if they could check that the browser executes JavaScript and then use that to permit you to do more work. Also, when I did my get with urllib2, there's all these embedded images on the page, like the Google logo. The Google could be checking that I'm actually downloading those logos, and if I fail to seem to be downloading the logos as often as I'm requesting the page, then I'm probably a bot. Or alternately, I'm somebody with images disabled.
You'd think the logo would be cached though, anyway.
Yeah, the logo would be cached, but there are other better examples. Like, they could actually add a little one-by-one image to every page to make sure that you're actually downloading the images. Yeah?
Even if it's cached, you tend to send a head request.
Say again?
Usually you send a head request with that.
Oh yeah, and if it's cached, you might check that
right.
that it's still safe to use the one from cache.
They're so overzealous trying to catch the bots that sometimes when you search from the browser, like Firefox search tool, it says that, yeah, I don't think I like you. I don't remember exactly what the error message is, but it's one of those, like, yeah, automated requests. No.
Yeah, Google in particular is really, seems to try really hard to prevent you from automatically using it very much at all.
Can you just
Yeah.
a bit over my head on that one? Why does it make such a big difference if it's cached?
Oh, well so let's say that they're trying to detect if you're a bot or a real web browser. So let's say they send you this image that's the logo, and they tell you to cache it in your web browser forever. Then they lose the ability to check if you're going to re-download that image as an indicator of if you are a bot or not. The phrase bot or not just opens up a whole world of possibilities, but that's another talk. So the other thing is that our user URL 2 didn't store cookies. So if this web browser sends us some data, if the website sends us some data that will then expect us to send it back, we won't do that. It might eventually catch on that we're not storing cookies at all. Maybe we're super privacy conscious, like law-abiding web browsers people, or we're just bots. And I think that there's still some interesting fingerprinting that I haven't seen being done, but I really want to see it being done. That where Google might give you links that don't parse in most HTML parsers, but that do in the browsers. And so then you wouldn't be able to click those. You wouldn't be able to easily find those links in the document if you used a bot if you use automated tools to parse the HTML, except a web browser's parser. But I just want to emphasize with this that there are a bunch of other ways to be detected than just setting your user agent. So it's not as if setting your user agent and you're golden. In fact, there's a really subtle one. So these accept headers. So we claim we want to hear about US English. And if not US English, then all English. All web browsers will send these, and they'll send these based on your configuration. You can actually change your web browser to request pages in French or other languages. Our bot doesn't send any accept language header. Our bot doesn't say it accepts gzip or slate. And every single time that Internet Explorer or Firefox or Chrome or Safari request a page with the user agent that's active themselves, they will every single time also set the accept encoding header. So if you set the user agent header for any of these things and you don't also configure accept encoding, maybe accept charset, maybe a keep alive header, you're obviously lying, but the server just might not be checking. I still think there's a world of opportunity for people to make fantastic bot detection tools. Yeah?
I think a good example you could use for the previous one where they omit HTML tags to thwart it is, I believe the homepage, if I'm not mistaken, is missing an HTML tag. Google homepage.
Oh, yeah.
If you view source.
Yeah, I think that's right. Why bother, right?
I wonder what happens when JavaScript requests a mouse pointer location.
Oh, it seems to. Oh, yeah. Well, you mean what happens in... Sorry, who said that?
I wonder if some JavaScript on the page will try to detect the mouse pointer location or things like that.
I mean, what will happen for us in the real web browser is if they ask it to, the web browser will send that information back to Google. And if it's a bot, then the bot will never get around to executing the JavaScript. So it'll send nothing. You'll be like, well, there's either no person driving this or they're smart and they disable JavaScript because they don't want the web browser to be broken into. But, yeah.
If you want a horrible example of HTML structure from Google, it's their 404 page.
Oh, interesting. Let's see. Yeah, there's no head, there's no body. This is awesome. This is like, this is getting up there. There's no quotes around this URL.
They actually encode the image in the CSS, which is awesome.
Well, that makes sense, actually.
Yeah, well, it's awesome. And the actual elements, they use the incorrect elements because they are less characters.
Yeah.
Like they use like B,
Right. They're using B instead of
as small
strong.
as possible.
Yeah. Yeah. Well, good for them. And we can probably parse this with this will definitely parse fine with HTML5 lib and Lxml.html.
But .lib HTML top, that's an HTML5 declaration.
Yeah, better. But of course, they could be lying. Maybe they made it non-parsing. In fact, did they do close HTML tags? I wonder.
No closing HTML.
No, why
closing
bother?
body.
Yeah, closing tags is cool.
Yeah.
Or no body at all.
So yeah, like if you think that setting the user agent header is enough, it's really not. Most of the time, it gets you by pretending to be that web browser, but it's not a perfect simulation.
Did you compare relative performance between the libraries in case you have to crawl a few million web pages?
There is. I'll get to that. Yeah.
In terms of that being a consideration, I mean, like if I get my mom's webpage on cats, she doesn't care. On the other hand, Google deeply cares. It's the sort of thing that we need to think about with the top 100 sites, top 1,000, top 10,000.
So the question was basically, for which sites, when you're scraping them, should you actually pay attention to trying to simulate a web browser effectively? Because there's some effort to go through that simulation. When should you bother? Is that a reasonable summary?
Only if they care.
Yeah, I mean, it's only if they care, and so it depends what the penalty is for failing. Usually you can just run some experiments, find out what they permit, and find out what sort of stuff they're checking for, and then just go. And the worst case is that you'll have that IP address blocked, or maybe you'll have that account blocked. I mean, if it's a more commercial application where you're violating people's terms of service to make billions of dollars, then, like, if you're going to make billions of dollars, you might as well just do it right anyway. But also, your crawling at the end of the day if you're doing a lot of crawling, it's going to be detectable. It has very statistically different patterns than people clicking around. And so it's both a matter of how much they'll care and how much you care. If you're only requesting a couple of hundred or a couple of thousand pages per day, you usually don't need to bother. That's been my experience. Yeah?
Are you going to talk about using WebDriver to simulate a browser?
Yeah. Yeah. And you can also just talk, well, we'll talk about that in a bit. So yeah, and again, like, in an Explorer, even 5 versus 8 makes a big difference as to what the server sends back to you. So there's another way that websites like to talk to bots. They like to tell them what they may and may not crawl. There's a file robots.txt that sits in the root of most websites, many websites, and it says things like, if your user agent is actually anything, I'm going to disallow you from crawling actually anything, except for this one thing, crawlme.html. So it's defined at robots.txt.org as a standard. If you ever request /robots.txt, it means you are a bot. If anyone wants to detect if you're a bot, and you crawl and you download that URL, you're done. Only, humans generally speaking, humans are like, oh, I wonder what the robots.txt file is like for this site. I wonder what things they permit Google to search. You might possibly, but it's bad news. So I want to, with that said, I want to talk about this tool Mechanize, which lets you fill out forms easily and keep cookies. So you can maintain a session with the server. So, we'll just do this here. So there's this great service on the web. For me, this is a classic example of the sort of API that didn't mean to be an API, misdeveloped. Yeah. So this will tell you the weather.
30-ish.
Okay. What does that mean? Great. Let's say we're in Cambridge. We want David to tell us the weather. Oh. Wow, I'm not very good at filling out web forms. I just want to replace by a robot. It'll give you this text summary of the weather and also an audio file. One of the interesting things for me about this service is that this is a demo of a particular text-to-speech product, but these voices are not available for download or purchase. So the only way you can access these voices is through this API right here, which, from as far as I'm concerned, is an API. So let's see how you would implement the consumer of that API.
Not if they see this.
What'd you say?
Not if they see this presentation.
I mean, well, they haven't taken it down yet. Okay, so let's pull this thing in again. And this time we'll keep the Firebug net tab open. Submit. Okay, so here's what we posted. Sitting inside here, the post data is this key values mapping of city to Cambridge, demo type to actual, submit to synthesize the weather, voice to David, zip to the empty string. I've copied that into here from a previous time when I was in San Francisco. And we can call this function to turn that dictionary into a string that HTTP expects as the formatting for that dictionary. Maybe I'll just quickly show you what that looks like. I agree. Let's see. Using URL encode. So it's a very simple encoding that URL serializes your dictionary to. We have to serialize it there, and then we pass it to urllib2. We give it the URL and the post data, and we get back whatever the server returns. I think that this computer doesn't have sound, but I did write a version of this that actually plays the WAV file that we get back. So it searches for a WAV file, a link to a WAV file, it makes it an absolute URL with URL parser URL join, because the link we get back just says like whatever.wave. It doesn't include the domain name of the server. We pass that in this totally unsafe way to mPlayer, and it plays it. And I think that
At 9 p.m., the temperature was 50 degrees Fahrenheit. The wind is from the north at 3 miles per hour. The barometric pressure is 3.3 inches and steady.
Nice.
So that's David and his API. They didn't document it very well, but they made it so easy to interact with that we didn't even need documentation.
How did you?
Yeah.
So how did you determine what it sent, what they expect? That's
Right. So it's pretty simple. You actually just do it. You submit it by hand, and then you look at this web page. And then in the web browser, you can inspect the response of the API. And you can see that there's some font class. Wow, that's weird. There's some link to a WAV file anyway. So does that answer the question there?
No, I was more wondering, how do we know what they expect to see from?
We're looking at the post request.
Yeah. So it's just the same way. The way that we get this page in the web browser is by filling out the form by hand, and Firebug will let you see what we posted inside the net tab. So if you just click the plus that's normally here, and you click on post, it shows you the key values that we submitted. So I just did that form submission by hand, in the sense that we called URL encode ourselves, we made this dictionary, but one kind of odd thing is that we posted directly to the URL without getting it first. So it's kind of as if we showed up, totally knew what the form would tell us to fill in, what the form fields would be, filled it out blind, submitted it, and then got back the result. The form can change over time. Maybe it requires a cookie. Um, and also, that's just a pretty suspicious thing to do to a website, to show up and submit data into a form without ever getting the form in the first place. If you're a regular web browser, you'll first go to this page, see this exciting information about the form, and then fill it in. So we can use Mechanize to do that. Mechanize is just a simple wrapper, mostly, around urllib2 that lets it handle cookies and forms. And it gives you a very imperative interface to filling out forms. So you create a browser object. Well, I've imported Mechanize at the top. We open this URL. We tell it that further operations on the browser object that are dictionary-like are about filling out the form. And then we submit. And this just does the same thing of returning us the file descriptor that points to the return, the HTML that gets sent back. If there were cookies that the server sent us, we would just store them fine and pass them along. Mechanize handles that for us. So in general, if you were thinking you should use urllib2, you should probably use Mechanize. It's just the same thing, but better.
Mechanizer handle like CSRF tokens and things like that?
The question is, will Mechanize handle CSRF tokens? Yes, so long as the CSRF tokens are in hidden form fields like they are in Django. If they're in something like JavaScript instead, then it won't. And that's actually something that our initial bot, would have failed at. But the great thing is, like, I can't even tell. I don't even have to worry about the CSRF stuff. It'll be handled for me by Mechanize.
So you say don't use urllib2, use Mechanize?
Yeah, definitely. Yeah, so these are the things that we did. We played the WAV file, which is great. So we can also search Yahoo with Mechanize to be a lot easier than filling out the form ourselves. So we can just create a browser object, go to Yahoo, search for PyCon, and submit. And if we do that, Yahoo will say that our requests have been disallowed by Robots.txt. But how did it know to disallow me? Actually, it's not Mechanize that banned me, it's myself that banned me. Mechanize read robots.txt, checked what parts of the site are disallowed for robots, and helpfully prevented me, the programmer, from using it to interact with that website. So you can disable that by calling this, which you should, as far as I can tell, always do. So once you call this, Mechanize will actually let the request go through. We don't do anything with the response, so it just prints nothing and exits, but it didn't fail. And also now Yahoo has reason to believe that there's bots. There's web crawlers running on this IP address. Luckily, it's their network, not mine. Yeah.
All right. What agent is Mechanize pretending to be?
It's a great
Is
question.
that a parameter you can set?
It is a parameter you can set. I don't think that these examples do that. Yeah, actually. So let me show you some demo code to search Google with Mechanize, where you have to set the user agent because Google bans you based on your user agent. You've already seen. So it's very similar to how you do with urllib2. You pass a list of tuples, that is the key values and headers to add. And again, like if we wanted to faithfully impersonate Internet Explorer 5 Windows 98, we would also accept encoding deflate. But whatever, good enough. Will it work? Will Google block us? Will we block ourselves? Will my package get dropped? It's right there. Yeah, so it prints the result, but it does in fact work if you set the iterations. So, you know, like filling out a form, this is a kind of convenient interface. So use it where you can. So to summarize what we had so far, you can load pages from the web with URL-lib2. You can parse broken ones with perhaps beautiful soup, but preferably HTML5lib and Lxml.html. You can use the tree parsing operations to convert that into whatever structure you need. And you've learned about status codes, you've learned about user agent header, and how to submit forms and handle cookies. I'm going to dive in a little more to these parsers. People ask questions like how they perform or what other advantages and disadvantages they have. In the real talk, I'll actually spend a bit more time on the performance. There's a benchmark by Ian Bicking that you all can find, and I can maybe send out a summary of this to the Python 181 list. But we'll talk about that in a second, I guess. If you're looking at parsers, you might want to have them be performant. Ian Bicking's blog post talks about that. They should be easy to use. They should not break in the face of broken HTML, and they should be maintained. Preferably not by you. So the standard lib, wow, I don't know why I don't have both at the same time. HTML parser and XML.dom.mini.dom are both part of the standard library, but you shouldn't use them. So, like, their behavior is different than actual browsers. Don't waste your time. They are really well maintained, I think, but you shouldn't use them. So, Beautiful Soup does a good job of handling broken pages and gives you this complex but powerful but confusing but convenient meta slick interface to searching document trees. HTML5lib gives you whatever interface to searching that you want. Usually I get back LXML trees from that, and Lxml.html works okay. Oh, wow, that's not what I wanted. I wanted less than sign. Yeah, so in the face of bad HTML, you want to pick either of these first two. Beautiful Soup is a close second. The stuff in the standard library is terrible. In terms of performance, Lxml.html can see if you can deploy Python C extensions where you are, that's great. It's super fast. Notice that it's also pretty resilient. The stuff in the standard library is pretty fast too. Beautiful Soup is slow, but HTML5lib is like 30 times slower. At least it was when I last benchmarked it. Yeah, so the winner to me is Lxml.html. You should basically always use it, and always use CSS select, unless you have any reason not to. Or maybe if you can't deploy Python C extensions where you are, which would be such a tragedy because it's so great. Whoa, pardon me. Yeah, so we talked a little bit about how websites can add countermeasures against scraping. They can check this refer header that browsers send. If you go from one page to another, your browser sends them a note that says, hey, I came from page A when you request page B. But I think that Mechanize doesn't send the refer header. And certainly, when we just post our data to the Cepstral David API, we didn't come from anywhere. So we didn't send a refer header at all. If Cepstral wanted to detect us as a bot, they could have looked for cookies that were set when we arrived on the site that permit us to use the form. If we just post data blind to it, we don't see those. Again, Mechanize takes care of that. The CSRF question was really about hidden form fields that sites use to track if you really came to the form from inside the site. And Mechanize handles those just fine. If you just blindly post to the URL, you'll fail to have those hidden form fields. So Mechanize handles all those pretty well. There's a bunch of really exciting countermeasures, though, that a lot of sites do really use. They limit the number of queries you have by IP address. They might, I haven't ever seen this, but I really don't know why. They could be checking if you're downloading the images and the CSS for a page before they permit you to use the form on the page. They could check if you're running JavaScript, checking your mouse position, things like that. And they could show you a little CAPTCHA that's like, are you really a human? So let's talk about that CAPTCHAs thing last. If you need to cycle through a bunch of IP addresses, there's a bunch of tools for doing this If you have a shell on some other computer, you can log into it using SSH's -D option, and then with this tool tsocks or socksmonkey. What I'm about to say might sound like total technobabble, but I'll expand it in a second. Maybe not. But if you log into that server using SSH-D, it lets you make a socks proxy that you can then route all your traffic through using one of two tools, tsocks or socksmonkey. Tsocks operates at the per process level. Socksmonkey is just a module you can insert into Python that patches the socket module to go through a socks proxy. Did I lose anyone there? Or
Did you not lose anyone?
Yeah.
Growth doesn't count.
Yeah, so maybe the shorter answer is, if you need to use a bunch of other machines' IP addresses, you should Google these things.
There are also proxies too.
Yeah, and there are other proxies you can use that you can either buy access to, or you can find lists of open proxies on the web, which may or may not actually write your traffic, or spy on you, or modify the data they send back to you.
Make a Python client for Tor.
Oh, yeah. Actually, let me show you how to do that.
Nice.
So some of you might have heard of Tor, which is an anonymity network. It lets you route traffic through other people's computers until it finally gets to the destination, so that your IP address is obscured. They only see the last person in the network talking to that server. And then that person relays the traffic through the network back to you. It's really simple to add Tor to any program, so you can just do torify Python. Wow. What about Tor sucks? Okay. So this will be really slow as we encrypt and send this across the internet. I wonder if that's our actual IP address.
Use icanhasip.com.
Wow. What? I have misplaced my terminals.
It's not our IP if you bring irrespective.
Well, I'll get back to that. I'm running low on time. But you can just use the program Torify or tsocks to route all your traffic through Tor. It'll be really slow, and if you're doing commercial things, taking advantage of this massive collection of anonymous volunteers who donate bandwidth to help people communicate freely in oppressive regimes, it's kind of a jerk thing to do en masse, automatically. Plus, it'll suck. It'll be really slow. So it's not actually what you want. Then again, if you're only doing a couple of hundred queries and you can wait a day for the response, that's okay. If they're doing behavior profiling, like I was saying, checking for images, like you're going to be found. Nobody does it though. I don't know why.
Could you use Amazon Turk?
Yeah, Mechanical Turk?
Yeah.
Yeah, so at one end of the spectrum, I suppose, is doing your web scraping using Amazon Mechanical Turk, where you hire individual humans at the rate of like 1 cent per URL they download to go to a web page, save the HTML, and send it back to you.
That sounds wonderful.
And then you process it automatically with all these automated tools. I guess
You probably
really
want to pre-create some tool that helps out.
Yeah, you can pre-create some tool that helps out.
Just read the captions.
You could do this for improving the quality of search or something. I don't know. If they really check that is
I think what the pros do for CAPTCHAs is they have a site with a lot of porn.
That's
Well,
right. They offer you porn for the
You just play the
CAPTCHA.
CAPTCHAs from the site.
Let's talk about CAPTCHAs while you're back. There's some really simple CAPTCHAs. If you're lucky,
I saw one with just a line through it.
this one's actually even better. You might believe it.
Some CAPTCHAs are appearing with little images of animals.
So Mailinator is a free mail service website, to make a long story short. They have a very limited number of CAPTCHAs. In fact, they have a fixed URL for each one.
I
and they increment in a very straightforward way. I think it's confusing though, because even though there's such a small number of them, this CAPTCHA is still gobbledygook. There's no solution anywhere.
Squiggly lines.
Yeah, so if it's an easy one like that, actually you can just download the images, make a, is that 10 minutes left?
Yes.
Okay, great.
Yes.
You can just make a Python dictionary that maps either the URLs to the solutions. Like, there's not that many of these. You can actually just go through them. There's like 6. When I first prepared this talk, they were using these in some security-sensitive-ish part of Melanator, as if that really exists in Melanator, for those of you who know the service. But now they actually don't bother using a CAPTCHA, and I think it's because their CAPTCHAs were just useless.
Number 8.
Sorry?
Look at number 8.
Okay. So, that was also probably easy to do OCR on. But that's not the best thing about this image. So, yeah, you can hash those by the image contents bytes, or you can hash them by the URL and look them up in a table. In a pinch, though, you can just block your app when it starts, show the CAPTCHA to a human operator, have the person type in the 6 letters, press enter, and then you begin your real crawling. And I've totally done that with reCAPTCHA, and it's great. You're a human when you need to be, and you're not when you don't need to be. Yeah. I also want to talk a little bit about JavaScript. There's basically 2 options if JavaScript is required. You can either find the JavaScript code in the source of the website and rewrite it in Python. So for example, if it's a really dynamic website that does a bunch of AJAX, you could calculate the stuff you're supposed to post back to this AJAX URL and download it with URL 2. That would be kind of labor intensive to rewrite somebody else's JavaScript in Python. Or you can actually instantiate the Mozilla JavaScript engine using a module called Python SpiderMonkey, pass the JavaScripts as a string into that, and then call functions inside it, and get the return values out as Python data structures. So that's a pretty reasonable alternative. And when I do this for real, I'll have a demo of using that to break WordPress hash cache, which tries to use an anti-comment spam system that you can totally break through with SpiderMonkey. Yeah, so then there's this sort of final heavy hammer, which is, I guess, all we'll have time for before questions. If you can just automate a Firefox, then you would slice right through all the behavior profiling. You slice right through the refer header stuff. So here's how you do it. For this, I use Selenium remote control. There's a bunch of other tools that do this also, Windmill, maybe some others, so-called lighter weight ones. Let me show you some source code, and then we'll actually run it. Right, but I'll have to first do that before we begin. Oh, wow. So here's some simple, if messy code. It's a class that happens to be a subclass from unit test.testcase. We're going to search Google. We found that Google has been trying really hard to block us the whole time. So whatever, we'll just give them actual Firefox. We'll start this web browser, and then inside the class, we'll go to the Google front page, click this link, click the Google, enter hello world into the search box, click the Google search button, and then wait for a while until the title has changed to hello world Google search. And at this point, we can extract information out of the contents of the document. There's this big long loop here, instead of it just being one line, because this is actually done using AJAX. So we can't tell when the page is loading using the Selenium normal mechanisms, and I had to hack this up half an hour ago. So in order for this to actually work, we have to also run this jar. Who knows what's in there? Let's just run it. So if you want to go through here.
It's already right.
It's like the best problem. Anyway. So let's run this. What?
School doesn't like you.
What is not finished yet? Okay, it was just taking forever. Okay, so we're gonna prepare a Firefox profile. We'll take a second. We'll launch Firefox. We'll take a second. So we'll load up two windows. One in the background that actually is where Selenium is, and the one in the foreground. It'll quit, and ta-da. It's true that the title of the page changed. But it's kind of a very quick demo where you can't see anything. So I could be faking it all. So let me just not stop Selenium.
Pass.
Pass.
Thanks.
Here's my cheat.
Yeah. So it'll still take like 20 seconds to launch the browser. So that's not, that's a lot longer than nothing. 20 seconds. Okay, so check it out. We have a little hello world Google here, and I didn't type anything, and here we are. Also, if we click this link, we'll go to a blacked out Wikipedia. What?
Eventually before it. There you go.
Okay, good.
Stuff.
Yeah, so actually, if we're scraping the JavaScript disabled, I guess probably it'll work.
Yep.
Okay. Pros and cons of using a real web browser. I don't know.
Use links.
That's right. We'll use Selenium remote control for links.
Use WPM.
There's one. So there is just one more thing I want to demo with Selenium.
We have 15 minutes for questions.
All right. So maybe I'll just, yeah, sure. Sure. So Selenium has this really convenient toolkit called the Selenium IDE that I apparently don't install in this Firefox profile. So I'll just tell you about it. Anyway, the Selenium IDE lets you click around in a web page, and it records Python code that maps to the actions you clicked on the web page. So if you click inside a form field and type something and press enter, it'll say select form whose ID equals form3, type text banana land, click search. Which takes all the messy work out of figuring out how to interact with forms. It does that in the Selenium remote control language, not in the language for Mechanize or for other url2, for example. But that's still pretty useful. And I still have Python, don't I? Yeah, okay, that's right. Yeah, so I think that's all I have for you for now. I would like to take some questions, and I know I have a lot of work to do. So thanks for suffering through this with me.
So we got 15 minutes for questions. We'll have to stay disciplined about it.
So sorry, because I'm leaving now because I have